At 6:47 a.m. on October 3, 1944, Private First Class Michael Kowalski sat in the driver's seat of an M4 Sherman tank near Aachen, Germany, watching through his periscope as fog lifted from the ridgeline to the east. Staff Sergeant Robertson stood in the cupola above him, scanning with binoculars. Intelligence had reported German armor in the area. Kowalski had been driving Shermans since the Normandy landings 4 months earlier. He knew what encountering Panthers meant. The Panther was superior in almost every measurable way. Better gun, better armor, better optics. American tankers had learned this the hard way in Normandy. The technical specifications told the story clearly. The Panther's 75mm KWK 42L/70 gun could penetrate a Sherman's frontal armor at over 2,000 yards. The Sherman's 75mm M3 gun could only reliably penetrate a Panther's frontal armor at ranges under 500 yards, and even then, only with perfect shot placement. The math was brutal and simple. In a frontal engagement, the Panther could kill the Sherman long before the Sherman could return effective fire. American doctrine had adapted to this reality. Tank destroyers and artillery would engage Panthers from the front when possible. Shermans would use their advantages: mechanical reliability, better crew ergonomics, faster turret traverse, and most importantly, better mobility. The official training emphasized flanking maneuvers. Get around the Panther. Hit it from the side where its armor was thinner, only 50mm instead of the 80mm frontal plate. A 75mm shell through the side armor would penetrate and kill a Panther reliably. The challenge was executing those flanking maneuvers under combat conditions. The Sherman used a controlled differential steering system, common in tracked vehicles of that era. To turn left, the driver pulled a lever that engaged the left brake band while maintaining power to the right track. The tank would pivot. To turn right, the same process in reverse. The system worked, but it had inherent limitations. When the driver pulled a steering lever, there was a mechanical delay before the brake band fully engaged. This wasn't a defect, it was how the system was designed. The brake bands needed to engage progressively to avoid shocking the transmission. That progressive engagement took approximately 0.4 to 0.6 seconds from the moment the driver pulled the lever until the brake band achieved full clamping force. During that delay, the tank would continue moving forward several feet before beginning its turn. At 15 miles per hour, a typical tactical speed, the tank would travel approximately 6 to 8 feet during that engagement delay. In open terrain training exercises, 6 feet didn't matter much. In combat, when trying to pivot around a building or terrain feature to achieve a flanking shot before a Panther could traverse its turret, 6 feet was the difference between exposing your side armor to enemy fire or achieving a protected firing position. Kowalski had first noticed this delay during training at Fort Knox in early 1944. The instructors acknowledged it existed, but explained it was within normal specifications for the Sherman's transmission system. The alternative instant brake engagement would have caused excessive wear on the transmission components and resulted in more frequent mechanical failures. The Army had chosen reliability over instantaneous response. That choice made sense from a logistics perspective. Keeping tanks operational in the field was more important than giving each tank marginally better handling. But it also meant that when executing the flanking maneuvers that doctrine emphasized, Sherman drivers had to account for that delay. They had to anticipate their turns, start the turn early, and accept that the tank would drift forward before it began to pivot. The problem was that combat didn't allow for careful anticipation. When a Panther appeared at 800 yards and started traversing its turret toward you, you had approximately 8 to 10 seconds before it could fire. If you were trying to get around a corner to achieve a flanking position, every fraction of a second mattered. Kowalski's first encounter with this problem had been near Mortain in early August. His platoon had engaged 2 Panthers that were covering a crossroads. The platoon leaders, Sherman, tried to swing around a stone barn to get a side shot. Kowalski watched through his periscope as the lead Sherman pulled left, drifted forward 6 feet before the turn began, and clipped the corner of the barn with its right track. The impact cost maybe 2 seconds of momentum. The Panther's turret had been traversing toward that position. The German gunner was experienced. He'd anticipated the American maneuver. When the Sherman appeared from behind the barn, the Panther was already aimed. The German fired. The shell penetrated the Sherman's turret. The American crew bailed out, but the tank commander and gunner were killed. Kowalski had filed that observation away. The Sherman's steering delay had cost the platoon leader those critical 2 seconds. Combined with clipping the barn, it had meant the difference between getting the first shot and being shot first. Over the following weeks, Kowalski paid attention to how the Sherman's steering behaved in different situations. The delay was consistent. Whether turning left or right, whether the tank was moving fast or slow, there was always that 0.4 to 0.6 second delay before the brake band fully engaged. He mentioned it once to a motor sergeant during a maintenance halt near Avranches. The sergeant acknowledged it, but explained there wasn't anything that could be done in the field. The brake band engagement was controlled by the friction characteristics of the band material and the hydraulic pressure in the system. Both were factory-set specifications. Adjusting the hydraulic pressure could make the brakes engage faster, but it would also increase wear and could cause the bands to grab too hard, potentially damaging the transmission. The technical manuals were clear. Brake band adjustment was to be performed only according to specification, using proper tools, and only when wear had exceeded tolerances. Field modifications were not authorized. By late September, Kowalski had been in enough engagements to recognize the pattern. When American tanks successfully flanked Panthers, it was because they'd had enough time and space to execute the maneuver despite the steering delay. When American tanks failed to flank Panthers and got hit, it was often because they'd been just slightly too slow getting into position. The 6-foot drift, the 0.6 second delay, had been enough for the Panther to complete its turret traverse and fire first. After one particularly difficult engagement near Maastricht, where 2 Shermans from another company were destroyed attempting flanking maneuvers, Kowalski found himself thinking about the problem differently. The brake band engagement couldn't be made significantly faster without risking transmission damage. That was a mechanical fact. But what if the brake bands were already partially engaged before the driver pulled the steering lever? If there was a way to preload the system, to take up some of that 0.6 second delay before it started, the tank would begin turning sooner. The pivot would start perhaps 0.3 seconds faster. The tank would drift forward only 3 or 4 feet instead of 6 to 8 feet. That might be enough. The challenge was how to preload the brake bands without causing them to drag continuously, which would waste fuel and cause premature wear. Kowalski thought about it for several days. The solution, when it came to him, was almost embarrassingly simple. The brake lever mechanism had springs that returned the lever to the neutral position when the driver released it. Those return springs had to be strong enough to overcome the hydraulic pressure that wanted to keep the brake engaged. What if those return springs were slightly weaker? The brake band wouldn't engage on its own because the hydraulic system was designed with that safety margin. But when the driver started to pull the lever, the brake would begin to engage fractionally sooner because there would be less spring resistance to overcome. Kowalski discussed this idea with his bow gunner, Private Tony Rossi, who'd worked in a garage before the war. Rossi understood mechanical systems. He thought about it and said the concept made sense, but changing the return spring tension would be a modification to the tank steering system. That would require authorization, and given how the Army felt about field modifications, authorization wasn't likely. Kowalski said he knew, but he also knew that 2 weeks earlier, Corporal James Martinez, a driver in another company, had been killed when his Sherman tried to flank a Panther and got stuck in a too-wide turn. Martinez had pulled left, the tank had drifted, and by the time it completed the pivot, the Panther had its gun on them. One shot. Martinez died instantly, along with his loader. Staff Sergeant Chun had lost 2 previous crews in Normandy. Both times, his tank had been knocked out attempting to flank German armor. Both times, Chun had survived by luck, thrown clear, or managing to bail out. He'd told Kowalski directly when they were assigned together in September, "I need this tank to turn faster than the manual says it can." I don't care how. Because if we can't get around Panthers before they can shoot us, we won't survive the winter. Kowalski decided to try the modification on the evening of October 1st. The company was in a maintenance halt near Würselen. Most of the crews were resting after 3 days of continuous movement. The motor pool area was quiet. Kowalski approached his Sherman with a small tool set. The steering brake mechanism was accessible through an inspection plate on the left side of the driver's compartment. He removed the plate and examined the system by flashlight. The return springs for the left and right steering levers were visible. They were coil springs approximately 4 inches long, mounted on rods that connected to the brake lever arms. The springs kept the levers in the neutral position when not being pulled. Kowalski studied them for several minutes. Simply removing part of each spring would weaken them, but it would also make them shorter, which would change the geometry of the lever system in unpredictable ways. He needed to reduce the spring tension without changing the spring length. The solution was to slightly stretch each spring. A stretched coil spring has reduced tension because the coils are already partially extended. Stretching the springs by perhaps half an inch would reduce their return force by roughly 10 to 15%. That should be enough to allow the brake bands to engage fractionally sooner when the driver pulled the lever, but not so much that the brakes would drag when the levers were in neutral. Kowalski used a small pry bar to carefully extend each return spring by approximately half an inch. He did this by unhooking each spring from its mounting point, stretching it slightly, and then reconnecting it so that it was under less tension in the neutral position. The process took about 40 minutes for both the left and right steering systems. When he finished, he tested the levers by hand from the driver's seat. They moved freely. The springs still returned the levers to neutral, but with noticeably less force. That was what he wanted. He replaced the inspection plate, cleaned up his tools, and returned to his bivouac area. He told no one what he'd done, not even Chun. Not yet. He wanted to test it first. If it didn't work, or worse, if it caused a mechanical problem, there was no point in implicating anyone else. The next morning, October 2nd, the company moved 10 miles east toward the Siegfried Line. Kowalski drove Chen's Sherman in column with the rest of the platoon. During the first hour of movement, he tested the steering carefully. The tank turned slightly more responsively. The delay between pulling the lever and feeling the tank begin to pivot seemed reduced, though it was hard to be certain while driving in column on a road. The real test came that afternoon. The company encountered a German roadblock, 2 Panthers and supporting infantry near a village called WWII. The American battalion commander ordered a flanking maneuver. Chen's platoon would swing north, use a tree lean for concealment, and try to get around the Panthers' position. Kowalski drove carefully, keeping the Sherman in the tree lean shadow. At 1,200 yards, the Panthers were visible through gaps in the trees. They were oriented southwest, covering the main road. Chun called the platoon's movement over the radio, coordinating with the other tank commanders. At 600 yards, Chun ordered Kowalski to turn left sharply, to circle around a small rise and come at the Panthers from their flank. This was it, the exact type of maneuver where the steering delay had killed other crews. Kowalski pulled the left steering lever hard. The Sherman responded. The turn began immediately, noticeably faster than Kowalski was accustomed to. The tank pivoted left and cleared the rise with perhaps 4 feet to spare instead of the 6 or 7 feet he'd expected to need. They emerged from behind the rise at a 75-degree angle to the nearest Panther, at 380 yards. The Panther's commander saw them immediately, started traversing his turret. But Chen's gunner, Corporal Eddie Williams, was already on target. The Sherman's turret had been pre-traversed to the left in anticipation. Williams fired. The 75 mm shell hit the Panther's side armor just below the turret ring. Penetration. The Panther stopped moving. Smoke began pouring from its engine deck. The crew bailed out. The second Panther was turning, trying to reorient. Chen's wingman got it with a flank shot before it could complete the turn. 2 Panthers destroyed. No American tanks lost. That evening, after the company had secured the village, Chun climbed down from the cupola and walked around to where Kowalski was performing post-mission checks on the tracks. Chun said, "That turned this afternoon. Around the rise. That was faster than this tank usually turns." "What did you do?" Kowalski hesitated, then explained. "The return springs. The reduced tension. The fractionally faster brake engagement." Chun listened carefully. Then he asked, "Can you do that to the other tanks in the platoon?" Kowalski said he could, but it was unauthorized. If a maintenance inspection found it, Kowalski could face disciplinary action. Modifications to vehicle control systems without authorization violated multiple regulations. Chun said, "I'll talk to Lieutenant Morrison." Lieutenant James Morrison commanded the platoon. He was 23 years old, a 1943 West Point graduate who'd arrived in Europe in July. Morrison had learned quickly that textbook armor tactics needed adaptation in combat. He listened to Chen's explanation, then asked to see Kowalski. Morrison questioned Kowalski carefully about the modification. What exactly had been changed? What was the mechanical principle? What were the risks? Could it cause a failure? Kowalski explained that he'd reduced return spring tension by stretching the spring slightly. The brake bands would engage fractionally sooner when the steering levers were pulled. The only risk was that if the springs were weakened too much, the brakes might drag slightly, causing increased fuel consumption and brake wear. But the amount he'd stretched them was conservative. Morrison thought about it. Then he said, "The company lost 4 Shermans last week. 3 of them were trying to execute flanking maneuvers and didn't get into position fast enough. If this modification helps tanks turn faster, it might save crews. Do it to the other 4 tanks in the platoon. I'll inform the company commander after we see if it works in combat." Over the next 2 days, Kowalski modified the steering return springs on the other 4 Shermans in the platoon. Each modification took about 40 minutes. The other drivers noticed the difference immediately during the next day's movement. The tanks turned more crisply, more responsively. On October 5th, Morrison's platoon engaged 3 Panthers near Crucifix Hill. All 5 Shermans executed flanking maneuvers successfully. The improved steering response gave them the split-second advantage they needed to get into position before the Panthers could traverse their turrets. 3 Panthers destroyed. 1 Sherman damaged by a near miss, but the crew survived. Morrison reported the engagement results to Captain Frank Collins, the company commander. Collins was a veteran of the Tunisia campaign, practical and focused on results. He asked Morrison how his platoon had achieved 3-for-1 kill ratios against Panthers. Morrison explained the steering modification. Collins listened, then made a decision. "Show our maintenance section how to do this modification. I want it on every Sherman in the company. If division asks questions, I'll handle it." By October 10th, every Sherman in Collins's company had modified steering return springs. The modification took on a life of its own through informal channels. Drivers talked to drivers from other companies during maintenance halts. "Our Shermans turned faster than they used to. Our drivers stretched the return springs on the steering brakes. Takes about 40 minutes. Makes a real difference in combat." Maintenance sergeants heard about it. Some refused to allow it, citing regulations. Others quietly authorized it after seeing the combat results. By late October, an estimated 30 to 40 Shermans in the 3rd Armored Division had the modification spread across multiple battalions. The modification spread was organic and unofficial. There were no written orders, no technical bulletins. Just drivers and maintenance crews sharing a technique that worked. The Army's official maintenance system became aware of the modification in early November, when a maintenance inspection team from 7 Corps noticed inconsistent steering return spring tension across multiple tanks in different units. The inspection chief, a major from Ordnance, questioned maintenance sergeants about why some tanks had different spring tension than others. The sergeants deflected, saying springs wore at different rates depending on usage. The major wasn't convinced, but didn't press the issue. He filed a report noting irregular maintenance practices regarding steering brake return springs in some M4 units. The report worked its way up to 1st Army Maintenance Command. An investigation was considered, but the timing was poor. The Army was preparing for a major offensive toward the Roer River. Maintenance Command decided to defer any investigation until after the offensive concluded. Meanwhile, the modification continued spreading. By mid-November, perhaps 80 to 100 Shermans had modified steering systems. The effect on combat outcomes was measurable but not dramatic. Units with modified tanks reported slightly better success rates in engagements requiring rapid maneuvering. The improvement wasn't revolutionary, just incremental. A tank that turned 0.3 seconds faster didn't guarantee survival, but in situations where that fraction of a second mattered, it made the difference. German intelligence never identified the modification as a specific change. German after-action reports from late 1944 noted that American Sherman tanks seemed to be executing flanking maneuvers more aggressively and with slightly better timing than earlier in the year. German analysts attributed this to improved crew training and experience rather than any mechanical modification. By December 1944, the modification had spread to parts of the 4th and 9th Armored Divisions through the same informal channels. The total number of modified tanks was probably between 120 and 150, spread across multiple divisions. This represented perhaps 8 to 10% of the Sherman tanks in the European theater at that time. The Battle of the Bulge in December 1944 disrupted the informal spread of the modification. Units were scattered, maintenance became crisis-driven, and the focus shifted to keeping tanks operational under extreme conditions. Some modified tanks were destroyed. Others were sent to depot-level maintenance, where the stretch springs were replaced with standard tension springs during routine overhauls. In January 1945, 1st Army Ordnance sent a team to investigate the steering brake modification. They interviewed drivers and maintenance personnel, examined modified tanks, and conducted control tests. Their report, filed in February 1945, concluded that stretching the steering brake return springs by 10 to 15% reduced steering engagement time by approximately 0.2 to 0.4 seconds. This provided a marginal but potentially tactically significant improvement in vehicle maneuverability. The report noted that the modification increased brake were by approximately 20% and slightly increased fuel consumption due to minor brake drag. The recommendation was that the modification not be officially adopted, but that field commanders may authorize this modification at their discretion based on tactical requirements, with the understanding that it will require more frequent brake maintenance. This was a carefully worded, bureaucratic compromise. The Army wouldn't officially endorse the modification, but it wouldn't prohibit it either. The decision was pushed down to field commanders. Some continued to allow it, others prohibited it to standardize maintenance procedures. By the war's end in May 1945, the modification had largely faded away. Post-war Sherman production included improved steering systems with faster brake engagement as a standard feature, though this was part of a broader series of improvements rather than a direct result of Kowalski's field modification. Michael Kowalski survived the war. He returned to Pennsylvania in August 1945, worked in steel mills for 35 years, married, had 3 children. He rarely spoke about the steering modification. When asked about his war service, he said he'd been a tank driver in Europe. That was all. Robertson also survived. He stayed in the Army, served in Korea, retired as a major in 1962. In his personnel files, there's a brief notation from October 1944. Tank commander, engaged and destroyed 3 Panther tanks near Aachen. Commended for tactical initiative. No mention of why his tank was able to execute the flanking maneuver successfully. James Morrison remained in the Army, retired as a lieutenant colonel in 1968. In a 1983 interview for an Army oral history project, he mentioned the steering brake modification briefly. One of our drivers figured out that if you reduced tension on the return springs, the brakes engaged faster. It wasn't much, maybe a quarter of a second, but in combat that could matter. We used it for a while. I don't know if it was ever officially approved, but it worked. The modification appears in scattered references in unit maintenance logs and a few veteran memoirs. Most histories of Sherman tank development don't mention it. It was too small, too informal, too undocumented to make it into the official narrative. But for the crews whose tanks turned just fast enough to get around a Panther's gun arc, for the drivers who executed flanking maneuvers with that extra quarter-second margin, the modification mattered. It wasn't the solution to the Sherman's disadvantages against German heavy armor. It was a small incremental improvement that gave some crews a slightly better chance. In war, sometimes that's enough. There are thousands of stories like this from World War II. Small innovations by soldiers who saw problems and improvised solutions. Most were never documented officially. Most of the men who created them didn't consider their contributions significant enough to mention. They did what needed doing, with whatever materials and knowledge they had, and then moved on to the next problem. These stories deserve to be remembered. Not because they changed the course of the war, but because they show how wars are actually fought, by ordinary people finding practical solutions to immediate problems, often in violation of regulations, always focused on keeping themselves and their friends alive. There are countless untold and unrecognized stories from World War II. It's our responsibility to bring them to light.